All right, in this video, we're going to talk about the slope of a line, or if you connect two points to form a line, what might the slope be of that line? So we're going to start with the deep one here. Our best friend are slope triangles, and what I mean by that is we know we could connect these 2 points with a straight line. But if you remember, there's this phrase called rise over what? Run. Now, what that means is a simplified way to say, look, what's your vertical and change, either up or down, and what is your horizontal change, left or right. And I want to remind you, when you go up, that's a positive. When you go down, that's negative. When you go left, it's negative. When you go right, it's positive. Okay, those are key ingredients to this whole rise over run thing, because if you just keep saying rise, then you're always going to have this idea that you always need to rise, and what if you can't rise? You got to go down. But with that thinking of rise over run, that's a good place to start, is at the bottom point, so that way you're guaranteed to rise and then run to the next point. So we're going to do that. We're going to create what we call a slope triangle, where we're going to rise, and then when we start getting to the next point, we're going to turn and run to it. So now I'm going to go back and count when I rise. So this, when I leave this dot, that's 0 when I'm there, but when I leave it and go to my first grid line, that's 1, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. We rose up. We went up 9, okay? I shouldn't put the positive there. That's a silly place to put the positive. Let's put it right there in front. Now when I got up to the top of that slope triangle, I turned and went left. 1, 2, 3, 4, 5, 6, but I went in the negative direction because I went to the left. So that means I ran 6 in the negative direction, so -6. That can be simplified. Divide both of those by 3 as 3 over -2. Okay? Now what's cool about this is, whoa, what if you said, Mr. Studell, like, yo, what if I forgot to start at the bottom dot, and I instead started at the top dot? No problem, I would say. Let's see what happens. So if you start up here, you're still going to go down, right? And then you're going to turn and run to that point. Now when I said down, I need to pay attention. 1, 2, 3, 4, 5, 6, 7, 8, 9, but I went down. That is a direction that says, yo, you went in the negative direction. So -9 would be in the numerator. Then when you run to the right, 1, 2, 3, 4, 5, 6, you ran in the positive direction. So +6 would simplify over to -3 divided by +2. And good news, friends, these are the same fraction. They're equivalent, okay? Now, for the mastery, there is, you could use a coordinate plane. You could plot these 2 points and see where they go, but this is designed for you to see if you remember that slope formula. And if you don't remember it, I'm writing it for you. And if you don't remember the slope formula, or maybe you do, great. Do you remember how to use it, right? And so now what we want to do is say, okay, how do I use these coordinates up here with the slope formula? Well, let's remind ourselves that there's an x and a y for each coordinate. And since you have a first set, we're going to call this x1 and y1. And we have a second set, we'll call that x2 and y2. And now what we do is substitute those values into the formula. So for example, y2 we said was -9. And then we're going to go minus the y1, which is 5. Then we go down to the denominator. X2 we said was going to be 3. That's key. Minus, the x1 is -8. So we got to go minus -8. And this is a good chance for us to review working with negatives. I have 9 negatives and 5 negatives. So a total of 14 negatives in the numerator. In the denominator, I see we're subtracting a negative, which is same thing as saying, hey, we're going to add 8. So that's 11 in the denominator. That is a fraction that really can't be reduced in terms of any common factors between the numerator and denominator. So we can leave it there as our slope, -14/11.